Okay, let's start with the next question. Find the convolution of the following signals and sketch the result. The question asks to find the convolution as well as to sketch the result. So we have given x of t and y of t. So let me first take you to a special note, because the duration of the first signal is 2 time units, whereas the second signal given by y of t is 3 units. Okay, so there is a difference in duration of this signal, and consequently, the convolution equation y of t, convolution integral, okay, convolution integral is given by minus infinity to infinity integral x of tau into y of t minus tau d tau. But convolution is commutative, so I can write it as y of t is equal to integral over minus infinity to plus infinity y of tau into x of t minus tau d tau. Why I have written this is because you have to take care that whenever two signals are asked to convolve with the difference in duration, then always take the lower duration signal as the second signal to convolve. Okay, second signal. So the second signal have to undergo some reversal, shifting, etc. Okay, it is x of t minus tau. Okay, so always choose the lower duration signal as the second signal. Okay, so this is a tip. And now we know the procedure, because y of tau is our first signal. We have y of t with us. To plot y of tau from y of t, just change the index from t to tau. Similarly for x of tau. So we have to first find or draw y of tau, then x of tau. I can write it here. First find y of tau, then draw x of tau, then x of minus tau, and finally x of t minus tau. X of t minus tau is obtained by shifting x of minus tau by t units. Okay, and initially we assume t is very less than 0. Okay. Alright, I have drawn y of tau and x of tau here. These two signals are in the index tau. Okay. Now looking at the parent equation, you have got y of tau here. This y of t is ready. But next you have to get x of t minus tau. But we have only x of tau with us. So the next procedure is to find x of minus tau. X of minus tau is obtained just simply by folding this signal about the y-axis. So this portion at tau equal to 2 comes to tau equal to minus 2 here. So I can write for you. Okay, now this is x of minus tau, right? Next we have to find out x of t minus tau. Then only we will satisfy this equation. So x of t minus tau, you have to get x of t minus tau by shifting x of minus tau t units. Okay, and initially this t is assumed to be negative, so that we have to shift x of minus tau t units to the left. Okay. Alright, so this is our x of t minus tau, because we have shifted this signal x of minus tau t units to the left. So this 0 becomes t here. Okay, we are shifting t, or we are adding t units, but this t is negative, so I have shifted it leftwards. So this is t, and this minus 2 becomes minus 2 plus t, because we are adding t here. Okay, t to every index, and the amplitude gets unchanged as 1. So this is x of t minus tau for t very less than 0. This is tau axis. Alright, now let us come back to the parent equation. What is y of t? I have to change this y of t, because the question itself is in y of t. So the output, let me change the name of the output to w of t. Okay, w of t, to avoid confusion, right? W of t. So my question is, what is w of t in this situation? Okay, in this situation, what is w of t? W of t is nothing but y of tau, the signal, multiplied by x of t minus tau, x of t minus tau, and integrating the result. Before integrating the result, what is the product? the product of these two signals is obviously 0, right? Because this signal is being multiplied by 0 here. Okay, corresponding we have 0 for this signal. So the output is 0. Therefore, I can write y of t. I can write y of t is, no, it is not y of t, w of t. Okay. So we can write w of t is equal to 0. Okay. Now imagine that I am slightly increasing the value of t. T was initially very, very negative. Now I am slightly increasing t, and what happens is the signal slightly move to the right. Okay. And then what is the product? Again, if the movement is slightly to the right, again the product is 0, because these two signals are non-overlapping, so the product is 0. And my question is, up to what value of t, if I keep on increasing, up to what value of t the product remains as 0? Up to what value of t? The answer is very simple. Up to t less than or equal to -2, the product w of t remains as 0. Right? Up to t less than or equal to -2. So we can consolidate this as w of t appears to be 0 till t less than or equal to -2. So this is our first condition. I can take one slide to consolidate these equations, results in various cases. So w of t equal to, first case, 0. What was the condition? T less than or equal to -2. Okay. So till t less than or equal to -2, w of t is equal to 0. Okay. Now what happens if t is greater than -2? What happens if t is greater than -2? Now the product becomes non-zero, is no more 0. Okay, let us check into that condition. Okay, so this is the case for x of t minus tau, where the t is greater than -2. Okay, now the product is non-zero. Initially, we have to find out the condition we are going to evaluate the output. The condition in which we are going to evaluate the output. So in this condition, I can always say that this leading edge of x of t minus tau, that is at tau equal to t, right? This leading edge comes overlapping with y of tau. Okay, that means the leading edge is greater than -2. Okay, the leading edge is greater than -2. That means t is greater than -2. And it's not over. And what happens to the trailing edge? This trailing edge is still behind y of tau. It's not overlapping with y of tau. Okay, the trailing edge is not overlapping with y of tau means -2 plus t is less than -2. Okay, so I can say -2 plus t or t minus 2. -2 plus t is t minus 2 less than -2. Okay, and if you look carefully, this is t greater than -2 and t less than, if you take -2 to this side, if it is t less than 0. So the interval is nothing but -2 less than or equal to t less than 0. Okay, this is the interval in which we are going to evaluate the w of t. So in this interval, what is w of t? W of t is equal to, from our parent equation, this is -infinity to infinity. This is the equation. We don't have to integrate from -infinity to all the way plus infinity, because the only region in the tau axis where this signals produce a non-zero output is this region. Okay, this region where these two signals overlap, just overlap or coincide. Okay, so what is that area or region? It is tau from -2 to t. Okay, -2 to t. It's the only region where these two signals, before -2, the signal is 0, so the product is 0, and after t, this signal is 0, so the product is 0. So only from -2 to plus t, the signal is going to get a non-zero product. So integral -2 to t, and y of t. What is y of t? Y of tau amplitude is 2. Okay, y of tau amplitude is 2. 2 into, what is x of t minus tau amplitude? That is 1. Okay, so 2 into 1 d tau, that is 2 into tau within the limits -2 to t. Okay, so that gives you 2 into t plus 2, which is equal to 2t plus 4. Okay, so this gives an insight to us about the output, that w of t is equal to 2t plus 4, where we have already derived the condition where minus 2 less than or equal to t less than 0. Okay, so I can consolidate this in the next slide. W of t is equal to 2t plus 4 within the limits minus 2 less than or equal to t less than 0. Okay, so we have arrived at two conditions for the output. Okay, what is the next condition that we are going to evaluate output? Next condition is we keep on increasing the t slightly. So what happens is this leading edge goes further into the y of tau region. So do the trailing edge. And now the next conspicuous condition is both the leading edge is already inside y of tau, okay, and now the trailing edge is also inside y of tau duration is higher, okay, so both the leading edge and the trailing edge are inside or comes under y of tau. Okay, let me draw that condition. Okay, this could be one such condition. The leading edge is greater than minus 2 or inside the y of tau. The trailing edge, which is t minus 2, is also inside. Okay, but here care should be taken that although t is greater than minus 2, but to say that this leading edge is still inside y of tau, you have to say that t is less than 1 also. Okay, this t is less than 1 also, then only we can say that x of t minus tau is completely inside y of tau. So to repeat, the leading edge is greater than minus 2, the leading edge is less than 1, and the trailing edge is greater than minus 2. Okay, so I can write the leading edge is greater than minus 2 and the leading edge is less than 1. Okay, and the trailing edge has now become greater than minus 2. Okay, what is this condition? I can write as t greater than minus 2 and t less than 1, and t greater than minus 2 means t minus 2 greater than minus 2 means t greater than 0. Okay, so if we consolidate these three together, we can say that t is greater than 0 and t is less than 1. Okay, because simultaneously t greater than minus 2 and t greater than 0 means t greater than 0 itself. Okay, so t greater than 0 and t less than 1, that means 0 less than or equal to t less than 1. Okay, so this is the next condition in which we are going to evaluate the output. So in this interval, our output w of t is integral. What is the limit of integration? Both the signals are overlapping, or whose product does not become 0, is only from minus t by 2, t minus 2 to t. Okay, t minus 2 to t. So integral t minus 2 to t, y of tau is 2 and x of tau has amplitude 1 d tau. So again it is 2 into tau, integral is tau from t minus 2 to t, and that will give you, when substituting the limits, t minus of t minus 2, which gives you t minus t plus 2, which is equal to 4. Okay, so our output w of t is equal to 4 in the interval 0 less than or equal to t less than 1. So this is our next case output. I can immediately update our consolidation. W of t is equal to 4, right? 4 for 0 less than or equal to t less than 1. Okay, right. All right, now we still keep on incrementing t slightly, and what is the next possible variation in the output? What happens? Or we can say that when this t is out of y of tau, but t minus 2 is still inside y of tau, right? This leading edge is out of y of tau, but the trailing edge is still inside y of tau. So what do we call that situation? that is condition is t greater than 1. T is out of y of tau means t is greater than 1, but the trailing edge is still inside y of tau means t minus 2 is less than 1. Okay, so t greater than 1 and t minus 2 less than 1 means t greater than 1 and t less than 3, or 1 less than or equal to t less than 3. Okay, this is a new condition. You can draw that condition. Okay, is this right? You can verify, right? The leading edge is it has gone out of y of tau, so t greater than 1, that's what we have written here, and the trailing edge, that is still inside y of tau, that means t minus 2 less than 1, that is what we have written here, and we have arrived at this condition, 1 less than or equal to t less than 3. So this is the next interval that we are going to evaluate the output. So w of t is equal to, inside this output, from the parent equation, you have it here, from the parent equation, integral minus infinity to infinity, but what is the limit of integration here? It is from t minus 2 to 1, right? T minus 2 to 1. It is the only area or region in the tau axis where these two signals coincide. Okay, integral t minus 2 to 1, y of tau is 2 and x of tau is 1, so 2 into 1 d tau, right? That comes to be again 2 tau within the limits t minus 2 to 1, and it will give you 1 minus t plus 2 into 2. Okay, so that is 6 minus 2t. 6 minus 2t. So the next output w of t is 6 minus 2t in the interval 1 less than or equal to t less than 3. 1 less than or equal to t less than 3. So this is our next case of output. We can immediately update our consolidation. So 6 minus 2t for the interval 1 less than or equal to t less than 3. Okay. Now, what is the next case of getting the output? As we further increase t slightly, what happens? This leading edge is already out of y of tau, right? Now, what remains is the trailing edge is also comes out of y of tau. Okay, the leading edge is already out of greater than t. I mean, the leading edge is already greater than 1, t greater than 1. I can write it as t greater than 1 already. Now, the trailing edge is also out of y of tau. That means you have to write t minus 2 is also greater than 1. Okay, so t greater than 1 and t greater than 3. Obviously, this is not needed, so t greater than 3. So the next output condition is at t greater than 3. So what happens to the signal x of t minus 2? In this case, t minus 2 is also greater than 1. T minus 2 and t. So what happens is the signal comes somewhere here. Okay. Alright. Now t minus 2 is obviously greater than 1. Now what is the output? W of t. Obviously it is 0 because there is no any overlapping portions for in common to both the signals x of t minus 2 and y of tau. So the answer is y of tau. I mean w of t equal to 0 for t greater than 3. Now our consolidation is complete. T greater than equal to 3, 0. Okay, so this is the final signal in expression in algebraic terms. But the question, I can invite your attention to the question, is to sketch this result. Okay, sketch the result. Fine. So now you need to sketch whatever we have obtained as w of t. Alright, now let us attempt to draw this w of t, sketch the signal output w of t. Initially, we can see that w of t is equal to 0 for t less than or equal to minus 2. So, in this part, the output is blindly 0. Okay. Now, what happens to the next portion from minus 2 to 0? Minus 2 to 0. What happens to this portion? The output is 2t plus 4. So how can you plot 2t plus 4? It's very simple. 2t plus 4 is having a slope of 2, right? Slope of 2 and an intercept, y-intercept of 4 units. Okay, so slope of 2 means in this interval of 2 units, the slope is actually 2, right? Slope is actually 2 and the y-intercept is 4. So to obtain a slope of 2 in 2 units, what should be the amplitude? It should be 4. Okay, so I can say this is the signal or signal portion 2t plus 4. Obviously the slope is 4. How can you calculate slope? It is y axis or delta y divided by delta x. Okay, delta y is 4 minus 0 and delta x 0 minus 2 2. Okay, so 4 minus 0 by 0 minus 2 will give you slope as 2. Okay, fine. So that's how you obtain or reach at 4 here, and obviously the intercept is 4, so this intercept is 4. So our answer is correct to this extent. Okay, and now let us check the next portion, 0 to 1. Okay, that means we are dealing with this interval. Okay, in that interval there is no any confusion, the output is constant 4. Okay, so the constant 4 output sustains here, right? Now the next interval we are going to deal with is 1 to 3. Okay, 1 to 3, again 2 units. All right, in that area the output we have obtained is 6 minus 2t. 6 minus 2t. So what is the slope here? Slope is minus 2. Okay, slope is minus 2 and intercept is 6. Okay, we need, I think in this interval we need only slope. We can have the output. So 1 to 3 minus 2 is the slope, right? Okay, now the last one is t greater than 3, the output is 0. So there is no any confusion. For all values for t greater than 3, the output is 0. Okay, so this is the actual output w of t signal, right? Okay, and if you are wondering how the intercept of this duration 6 gets us, it is nothing. You extrapolate this signal to this area, this axis, you will get 6. Then it is clear that the intercept is 6. Okay, so anyway, okay, so this is the final answer, and I think we have passed some 15 minutes to explain this or do this. But there is a tip, especially for students who are preparing for competitive examination. They can have a tip which by which we can solve this question within 1 minute. The tip is, first of all, let me go to the question slide. Right, here the two signals we are convolving are of different duration, right? So in such cases, the output you're going to expect is a trapezoidal signal. Okay, what we have obtained here is a trapezoidal signal. Okay, and if at all the inputs are of same duration, then we are going to get a triangular signal, just a triangular signal. There won't be a constant term here. Okay, now let me tell you the tip. Let me draw the input signals x of tau, x of t. All right, these are the input signals. So this is of duration 2, this is of duration 3, right? So the output signal starts at 0 plus minus 2. Okay, 0 plus minus 2 is minus 2. So our output signal is going to start at minus 2. All right, now we know that the signal we are going to observe as output is a trapezoidal signal. We have already mentioned that because of the different duration. Okay, now there will be a rise time for this trapezoidal portion, right? This portion. I'm going to give you the duration of that rise period. That duration will be lowest of the input signal. Which signal is having lowest duration, that duration will be the rise time for this rise portion. Okay, so here 2 is the smallest portion, so we have duration 2. That means minus 2 to 0, we are going to get a signal like this. Okay, a rise. And what will be the slope of this rise? The slope of this rise will be the product of the amplitudes of two signals. That is 2 into 1 is 2. Slope is equal to 2. So if the slope is 2 for 2 duration, this is 4. This amplitude should be 4. Okay. Now listen carefully. Now, as this is a trapezoidal signal for sure, there will be a fall time also. Okay. This fall time will be same as this duration. That means 2 units. Okay. Keep that. And what is the end point of the signal, output signal? That should be the end value, sum of end value of both signals. That means 2 plus 1, 3. Okay, so 3 is the end value, and you are going to get a fall at this portion also because it is a trapezoidal signal. So, and what is the duration of this fall? It is also same 2 units. Okay, this 2 units also comes here. Therefore, this is 1. Right. Okay, and the slope will be minus 2. Minus the product of this amplitude and this amplitude. So, minus 2. And the remaining portion is 4. Okay. So, within 1 minute, less than 1 minute, we can obtain the output WT. Okay, the next question is, find the convolution of the following sequences using matrix multiplication method. And you have given x of n and y of n. Okay. So, by matrix multiplication method, that might be indicating the tabular method. So, we can, you know how to find out the convolution very easily using tabular method. First, we have x of n is equal to 1, minus 2, 3, 1. And the arrow at minus 2 indicates n equal to 0, sample is minus 2. And y of n is given as 2, minus 3, minus 2, where n equal to 0 is the sample minus 3. Now what we do is, we write the coefficients of x of n either vertically or horizontally. No problem. There is no restrictions to the order because convolution is commutative. So I have drawn x of n coefficients here, and y of n, I'm going to plot the coefficients here. 2, minus 3, minus 2. Okay. Now you know what we are going to do is to multiply corresponding cells. Okay, multiply the entries in corresponding cells. So in this cell we are going to plot 1 into 2 is 2. Okay, so here it will be 1 into minus 3, that will be minus 3. Here it should be 1 into minus 2, minus 2. Similarly, here is minus 4, here it is plus 6, here plus 4, 6, minus 9, minus 6, 2, minus 3, minus 2. Okay, now select the resultant products in a diagonal fashion. I'm separating these elements in a diagonal fashion. Okay, now I'm going to accumulate all the entries inside each diagonal separately. That is our final answer. The final answer may be x of n convolution y of n is equal to, there is a single 2 in this diagonal, so write it as 2. Okay, in the next diagonal we have minus 4 and minus 3, so add minus 4 minus 3, you will get minus 7. So minus 7. Then in the next diagonal we have 6 plus 6 plus minus 2 is 10. Then in the next diagonal, 2 minus 9 plus 4 is minus 3. Okay, in the next diagonal it is minus 3 and minus 6, which add you to give minus 9. And in the last one it is minus 2. Okay, so this is the answer, but it is still not over because we haven't specified which sample comes at n equal to 0. So what is the easy way to determine the sample at n equal to 0? Because if x of n starts at n equal to n1, if y of n starts at n equal to n2, then x of n convolution y of n will start at n1 plus n2. Okay, so here in x of n, n1 is equal to minus 1, right? Because this sample is at n equal to 0, so this sample is going to be at n1 equal to minus 1, right? So n1 is equal to minus 1. What is n2? This sample start at n equal to 0, so this sample will start at n2 equal to minus 1. Okay, so n2 equal to minus 1. So x of n convolution y of n will start at minus 2. Okay, so this sample is at n equal to minus 2. So this sample is at n equal to minus 1. So this sample is at n equal to 0. So we have to put the arrow mark below 10. That completes the answer. That's the next question. Show that any signal can be represented as the summation of an odd and an even signal. That's the first part. Then write down the expression for the odd and even components of the signal x of t and x of n. And finally, find the odd and even components of the signal given x of n. Alright, let us start the second session first. Okay, here we have a question. Write down the expression for the odd and even components of the signal x of t and x of n. Let me start with x of n. The even part of any discrete time signal x of n is given by x of n plus x of minus n whole divided by 2. So this is the definition 1. Right. Similarly, odd part of any signal x of n is given by xo of n, which gives as x of n minus x of minus n whole by 2. This is definition 2. So that completes the second part. Right. Now, using this definition, we have to show that any signal can be represented as a summation of an odd and even signal. Okay. To prove that xe of n and xo of n summate to give x of n is very simple. We just add xe of n and xo of n, which will give you x of n plus x of minus n plus x of n minus x of minus n whole divided by 2. Okay, that gives you these two terms cancel and give 2x of n by 2, which is equal to x of n. So we have proved that the even part of the signal x of n and odd part of the signal x of n both add to give that same signal itself, x of n itself. Okay, now next I have to prove that this odd and even component are odd and even, right? Summation of odd and even components. So my next aim is to show that this xe of n is odd. So xe of n is even. Let us see. What is xe of minus n? Xe of minus n means you replace n with minus n. Okay. So this is x of minus n plus x of n by 2. Okay. That is same as xe of n. So what you have obtained is xe of minus n gave you xe of n. Therefore, xe of n is even part, even component. Okay. Now similarly, let us do xo of n. We have to be sure that xo of n is an odd component. Okay. So I'm taking this equation, and from that xo of minus n is calculated. So replace n with minus n in the RHS. That will give you x of minus n minus x of n by 2. That is equal to minus of x of n minus x of minus n by 2. That is nothing but minus xo of n. So what you have got is xo of minus n is equal to minus xo of n, which is enough to show that xo of n is odd component. Okay, so that's the answer to the second part too. And finally, you are asked to find out the odd and even components of x of n given. So we move along to solve this question. Find the odd and even components of x of n. So x of n is given as, let me rewrite it, sequence -2, 1, 2, -1, 3, where an arrow is given below 2, which indicates that the sample 2 is at n equal to 0. Okay. To find out the even component, we know the equations. Xe of n is equal to x of n plus x of minus n whole divided by 2. And odd component is x of n minus x of minus n whole by 2. Okay. So immediately what we need to find out is x of minus n. How can you find out x of minus n from this sequence? You just flip it around. You imagine that it is a graph. Okay, imagine that it's a graph like this. We have 2 at n equal to 0, minus 1 at n equal to 1, 3 at n equal to 2. Similarly, 1 at n equal to minus 1 and minus 2 at n equal to minus 2. Okay, so imagine like that. Now what is x of minus n? You just flip or fold the signal about the y-axis. So the sample at n equal to 0, that is 2, remains there itself, and other samples, minus 1 goes to this position, 3 goes to this position. Eventually 1 at n equal to minus 1 goes to this position at n equal to 1, and minus 2 at n equal to minus 2 goes to this position at n equal to 2. So I can complete it as minus 1, 3, then 1, minus 2. Okay, so this is x of minus n. So we got x of n and x of minus n. Now we find out barely xe of n. Therefore, or we can find out x of n plus x of minus n. You just add the corresponding sample values. So you add minus 2 and 3, that will give you 1. Then you add 1 and minus 1, 0, 2 plus 2, 4, 1 plus minus 1, 0, 3 minus 2 is 1, but do not forget to multiply it by 1 by 2. Okay, so I will do it in the next step. Therefore, x of n plus x of minus n by 2 is equal to half, 0, 2, 0, half. Okay, which is our even component. Okay, now to find out odd component, we have to find out x of n minus x of minus n. Okay, so provided you know these two values, I can always plot x of n minus x of minus n. Again, subtract x of minus n from x of n, corresponding samples. So minus 2 minus 3 is minus 5, 1 minus minus 1 is 2, 2 minus 2 is 0, minus 1 minus 1 is minus 2, and 3 minus minus 2 is 5. Therefore, this is just x of n minus x of minus n. We have to find out x of n minus x of minus n whole by 2. That is minus 5 by 2, 1, 0, minus 1, and 5 by 2. So this is our odd component. Okay. And before closing, we have to be sure that the even component given by this equation is symmetric about the y-axis. Of course it is symmetric. Okay, so this is the y-axis. With respect to y-axis, 0, 0 on both sides, half and both sides. So it is symmetric about y-axis. And similarly, we have to make sure that xo of an odd component is anti-symmetric about y-axis, right? This is at n equal to 0. So minus 1 and 1 are anti-symmetric. 5 by 2 and minus 5 by 2, they are also anti-symmetric. So our assumption and answer are correct. So these are anti-symmetric about y-axis. That completes the solution. Next is a convolution problem. Given signals x of n and h of n. But take care that these two signals are infinite signals. X of n is 1 by 3 raised to minus n. U of minus n minus 1 is an infinite signal. So is h of n. So in this case, you have to follow the procedures like that we have followed in convolution integral case. Okay. So initially, we are going to plot x of k and h of k. So I have drawn x of k in the index k. If you have any doubt how to obtain x of k, just listen. X of k is actually 1 by 3 to the power minus k, u of minus k minus 1. 1 by 3 raised to minus k, u of minus k minus 1. What is 1 by 3 raised to minus k? 1 by 3 raised to minus k is 3 raised to k itself, right? So that should be a signal like this. Yes, increasing exponential signal. This is 3 raised to k. And this is multiplied by u of minus k minus 1. What is u of minus k minus 1? U of k minus 1, u of k is this signal, usual step signal. U of k minus 1 means we are shifting the signal 1 unit. Okay. So the signal will start from 1, just 1. This is u of k minus 1. What is u of minus k minus 1? You flip it about the y-axis, time reversal. So that will be from minus 1 to left side. Okay, this is u of minus k minus 1. So if you multiply 3 raised to k and u of minus k minus 1, the result will be an exponential signal from minus infinity to minus 1. That is shown here. Okay. Alright, next we can draw h of k. So this is h of k. H of k equal to u of k minus 1, where the step signal u of k is shifted by or delayed by 1 unit. So it starts at k equal to 1. Now what we want is h of minus k, which is obtained by flipping or folding this signal around the y-axis. So this signal is h of minus k. Okay. Now we have to remember the convolution sum equation is y of n is equal to sigma over k equal to minus infinity to plus infinity x of k into h of n minus k. To realize this equation, x of k is needed and we got it right now, and h of n minus k is to be needed, but we have only h of minus k here, right? So we have to find out h of n minus k, which can be obtained from h of minus k by shifting n units to the left initially. Okay. So initially assuming n is very less than 0, negative. So so this value will be minus 1 plus n. Okay, and it is an infinite signal. Okay, now we have to find out the summation y of n equal to sigma k equal to minus infinity to plus infinity x of k into h of n minus k, which is sigma k equal to minus infinity to, what is the upper limit of the summation? You don't have to integrate up to, you don't have to sum it up to plus infinity, but you need to sum it up to minus 1 plus n, because after minus 1 plus n, in these values, the product is turning out to be 0. So k equal to minus infinity to minus 1 plus n is actually n minus 1. Okay. Now, in that case, x of k, we know the expression for x of k, which is 1 by 3 to the power minus k. 1 by 3 to the power minus k into, what is h of n minus k? H of n minus k is 1. All samples are 1. So into 1, that appears to be, this is actually 3 raised to k, right? Sigma k equal to minus infinity to n minus 1, 3 raised to k. So giving values for k, take care that k values are negative. So first value is 3 raised to n minus 1 plus 3 raised to n minus 2 plus 3 raised to n minus 3, and it goes to infinite terms. Okay, so this is an infinite GP. the sum of an infinite GP, you know it is S equal to A by 1 minus R. Okay, here A is equal to 3 to the power n minus 1. R is equal to, what is R? R will be equal to 3 raised to minus 1 or 1 by 3. To take care of the case that mod R is less than 1, right? Mod R is less than 1, so we are safe to use this equation, no problem. So the sum is actually equal to 3 raised to n minus 1 by 1 minus 1 by 3, which will give you 2 by 3 into 3 by 2 into 3 raised to n minus 1, which is equal to 3 raised to n by 2. Okay, so this sum holds up to when we increase n, this signal goes to right side. Okay, so up to this holds up to the sample minus 1% reaches minus 1. Okay, up to here this value holds. Okay, so we can say this y of n is equal to 3 raised to n by 2 till minus 1 plus n is less than or equal to minus 1. Or in other words, n less than or equal to 0. So that's the first condition of our output. Now the next condition is as we move this n, or as we increment this n, this sample moves this direction and crosses minus 1 point. Okay, and crosses minus 1 point. That is the next condition. So this could be one such case where the n minus 1, the leading edge, is outside x of k. Right. So what is this condition called? N minus 1 is greater than minus 1. Previous case, n minus 1 was less than or equal to minus 1. Now n minus 1 is greater than minus 1, or in other words, n greater than 0. Okay, so we are going to evaluate y of n at the interval n greater than 0. So sigma k equal to minus infinity to infinity x of k into h of n minus k is actually sigma k equal to minus infinity to minus 1, right? We need to take summation up to minus 1 only, because after minus 1 this x of k is 0. Okay, so minus infinity to minus 1, 3 raised to k into 1. Okay, so we have to substitute value for k from minus 1 to minus infinity. So 3 raised to minus 1 plus 3 raised to minus 2 plus etc. and goes to up to infinite terms. Again, this is a GP, infinite GP with common ratio 1 by 3. So we have to use the sum expression, and you will get a by 1 minus r means first term is 3 raised to minus 1 by 1 minus 1 by 3. And you will get 3 by 2 into 3 raised to minus 1, which is equal to 1 by 2. Okay, therefore y of n is equal to 1 by 2 for the interval n greater than 0. These two are the intervals. There is no any further intervals. So consolidating our answer, y of n is equal to 3 raised to n by 2 for the interval n less than or equal to 0, and 1 by 2, 0.5 for n greater than 0. So this is the final answer.